Okay, what I'd like to talk to you about in this video is how we go about finding the trigonometric function values of any angle theta, not just acute angles that would be in quadrant 1, but in any angle in any axis in a quarter plane. First problem reads, find the remaining trig function values if it is given cosine of theta equals -5/12 and the sine of theta is less than 0. The first thing that we need to do is determine in which quadrant this angle is going to be in. So I might go ahead and set up an XY axis. And I like to go ahead and label my axis as to, or my quadrants as to which trig functions are positive in which quadrant. So I might label the quadrants like this. A, S, T, C. That stands for all students take count. All in the first quadrant are positive, sine in the second quadrant, tangent in the third quadrant, and cosine in the fourth quadrant. So it tells us here that the problem that the cosine of theta is a -5/12, but specifically that the cosine is negative. Well, we know if the cosine is negative that it cannot be in the first quadrant, because all trig functions are positive in the first quadrant, and it cannot be in the fourth quadrant because the cosine is positive in the fourth quadrant. So knowing that the cosine is negative narrows us down to 2 quadrants remaining. Well, the extra information here, given that the sine of theta is less than 0, means that the sine of theta is negative, will help us narrow down out of the remaining 2 quadrants. Well, if the sine is negative, and in quadrant 2, where I see an S, means the sine is positive there, that means I can throw out quadrant 2. I want a negative sine value. So the only place where cosine is negative and sine is negative is in quadrant 3. So in quadrant 3, we go ahead and sketch our triangle. Okay, so now I need to label on that triangle my 3 sides. Cosine labels adjacent divided by hypotenuse. Well, since the hypotenuse cannot be a negative value, we'll go ahead and label it positive. That makes the adjacent become -5. And now what we need to do is figure out what is the length of the opposite side. The opposite side can be found using Pythagorean's theorem. So Pythagorean's theorem for this last side would tell us -5 squared plus x squared equals 12 squared. So x squared is going to be equal to 119. So x is equal to the square root of 119. And because that length is going down, we need to label a negative square root of 119. Okay, so now we want the remaining trig function values. We're ready to go ahead and start writing those out using our opposite, adjacent, hypotenuse definitions. And let's just kind of fit them in right over here. Sine of theta. Sine is the opposite over hypotenuse, so we're going to label that negative square root of 119 over 12. Now it might be easy to go ahead and label the cosecant at the same time, since cosecant is just the reciprocal of sine. That would make it -12 square root of 119 over 119. Let's see, cosine we've already got. Cosine of theta is equal to -5/12. That means its reciprocal function, secant, is equal to -12/5. Tangent of theta is equal to opposite over adjacent, negative square root of 119 over negative 5. And of course, we've got two negatives here. Negative divided by negative is a positive, so I might go ahead and take those negative signs off of there. So we read positive square root of 119 divided by 5. Cotangent is the reciprocal. It's of course going to be positive as well. 5 square root of 119 over 119. Okay, try another example here. Find the 6 trig function values if the point negative 4, 5 is on the terminal side of angle theta. Okay, so the first thing we need to do is sketch an xy axis, plotting that point negative 4, 5. I'm going to predominantly show quadrant 2, since the point negative 4, 5 would be plotted in quadrant 2. So negative 4, 5 would put it up here somewhere, going 4 to the left, and 5 up. And so my triangle is labeled negative 4 on the x, 5 on the y, and then with Pythagorean's theorem, we can find the third side, negative 4 squared plus 5 squared equals x squared. So if we square, we get 16 and 25, those add to 41. So my hypotenuse is the square root of 41. Now, once we get the triangle set up, you'll find it just like the other problem. We're ready to write out our ratios. Sine is opposite over hypotenuse. That would make it 5 divided by the square root of 41, which is 5 times the square root of 41 over 41. Cosecant is just the reciprocal, square root of 41 over 5. Cosine is adjacent over hypotenuse, so we have a negative 4 divided by the square root of 41, so negative 4 square root of 41 over 41. Secant is its reciprocal. It'll take the square root of 41 over negative 4. And the tangent of theta is opposite over adjacent, so we'll go with negative, and then 5 over 4. And then cotan is its reciprocal, negative 4/5. Okay, the next slide, let's just review real quick our x, y, r definitions for sine, cosine, tangent, and their 3 reciprocals. Might speed up a problem like that last one where we don't really need to draw the triangle. Recall that sine is equal to the y coordinate divided by r, cosine is the x divided by r, tan is the y divided by x, and then cosecant, secant, cotangent are just the reciprocals. And of course we need to go ahead and add, just a reminder, that r is the square root of x squared plus y squared. And that comes from Pythagorean's theorem. Okay, so that same example number 2, let's treat it a little bit differently. Let's just avoid drawing the triangle completely. I've got an x value. I've got a y value. We can find the r value. It's the square root of negative 4 squared plus 5 squared. We should find r to be just as it was before, because it's really the hypotenuse of that triangle. With that x, y, and r, we're ready to go. Sine is the y coordinate divided by r, which is 5 divided by square root of 41, or 5 square root of 41 over 41. Cosine is the x divided by the r, so that would be negative 4 square root of 41 over 41. Tangent is the y divided by x, negative 5 over 4s. And of course then you could flip over all the ratios and you could find cosecant, secant, cotangent. But they will, of course, be the same values they were on the previous slide, the previous problem. Okay, I hope this has helped you to find the trig function values of any angle, not just the acute angle. It basically just boils down to drawing a triangle and using that triangle in any quadrant. So it's really just like the acute angles are.